In the next two examples, we're going to be finding the greatest common factor of a polynomial, but you'll notice this time we have exponents that are much larger than 1. So we're not going to let that worry us. We're still going to start with each coefficient. So we're looking at 80, 65, and 20. We're going to break those down using the factor ladders to come up with the greatest common factor for the coefficient portion, and then we'll look at each of the variables involved for these terms. So if I begin with 80, I want to break that down into factors and think about prime factors that 80 is divisible by. So I can divide that by 2. That leaves 40. 40 divided by 2 again would leave 20. 20 divided by 2 leaves 10. And I might as well keep using 2. That would leave 5. But now 5 is not divisible by 2. So the next prime number that 5 would be divisible by is 5. 5 divided by 5 leaves 1. So along this edge, 2 times 2 times 2 times 2 times 5, those are the prime factors of 80. Next, we're going to break down 65. So starting with 65, since that is not an even number, I know that I can't use 2. But since it ends with 5, I know that it is divisible by 5. 5 goes into 6 one time with 1 left. 5 goes into 15 3 times. Now 13 is not even. It doesn't end with 5. And 13 is actually going to be a prime number. So I can divide it by itself to leave 1. So the factors of 65 are 5 and 13. Finally, we have the number 20. Dividing 20 by 2, we get 10. Dividing 10 by 2, we get 5. And 5 can be divided by 5, leaving 1. So what we're looking for is what is in common for all three of these coefficients. So I've got a 5, a 5, and a 5. All of these factors have, all of these coefficients have the factor of 5 in common. Now I see a lot of 2's. There's some 2 involved with 80, but there's no factor of 2 for 65. So we can't use 2. 13 is not in common for all three. So the only common numerical factor will be 5. So I'm going to start with 5. Now I'm going to look at all of the variables. We have x and y in the first term, x and y in the second term, x and y in the third term. So we know that all terms have x and all terms have y. So I'll start with x and y. Now I compare the exponents for these terms. 5, 5, and 4. Those are the exponents for the base of x. We have to go with the exponent that is the smallest because that is the guaranteed amount to find in all terms. So that means x to the 4th is the greatest amount of that base of x that can be found in all terms. We do not go with the largest number because x to the 5th is not found in that last term. Now we're going to look at our bases of y. Exponent 5, exponent 1, exponent of 2. So whichever of those exponents is the smallest one, that's how much of that base is found in all the terms. So that would be y to the power of 1. So that's just y. Now we're ready to fill in the missing factor. Now we're ready to fill in the missing factor. What we have to do sort of is reinvent the wheel. If we're starting with 5, what would we multiply it by to get 80? You can use your calculator, take 80, divide it by 5 if you need to do that, or you can do some long division off to the side. So we're going to get 5 times 16 makes 80. Now we go to the variables. We have x to the 4th. We need x to the 5th. So do you see how there's an x missing? So we'll include the x. Now compare bases of y. We have y to the power of 1. We need y to the power of 5. How do you get from 1 to 5? We're missing 4. So y to the 4th is needed. What we're actually doing here is applying the product rule of exponents. 1 plus 4 makes the 5. So when you have multiplication of common bases, remember to add the exponents. Next, we have to match our middle term. 5 multiplied by something has to match positive 65. So 5 times 13, and that would be positive 13, will make 65. Now compare your variables again. X to the 4 is what we have, but we need x to the 5th. So we need one more base of x. Base of y to the 1st is what we have. We need y to the 1st. Well, that's already an exact match. That tells us we don't need any more y. So I don't write any more bases of y. We're ready to match the last term now. We're starting with 5. We need to match positive 20. So 5 times positive 4 would match 20. Now compare the variables. X to the 4 is what we have. X to the 4 is what we need. They're exactly the same. That means we do not need any more bases of x. Base of y to the 1st is what we have. Y to the 2nd is what we need. So it looks like we need one more base of y. Close it with the parenthesis. So our final answer includes 5x to the 4th y multiplied by this quantity. For our final example, we have 27x to the 5th, y to the 7th, minus 33x to the 3rd, y 3rd, minus 78x squared, y to the 4th power. So we're curious about if 27, 33, and 78 might have a common factor. So we'll just use our factor ladder and start our division process. So 27 is not even, so I'll start with division of 3. That leaves 9. Dividing by 3 leaves 3. And again, dividing by 3 leaves 1. Our next number is 33. Don't worry about the negative at this point. Just look at the coefficient 33. 33 is divisible by 3, leaving 11. 11 is also a prime number, so we can divide it by itself to get 1. Our last coefficient is 78, and that is an even number, so I'll start with division of 2. 2 goes into 7 3 times, leaving 1. 2 goes into 18 9 times. Now 39 is not even, so that looks like I can divide by 3. 3 goes into 3 once, 3 goes into 9 3 times. And now we are left with 13, which is a prime number, so that can be divided by itself, leaving 1. Now we're ready to see if there are any numerical coefficients the same for all 3 of these coefficients. And I notice that 3 is found in each one of our coefficients. Now all I have is factors of 3 for 27. I don't have 3 to circle again for all of these coefficients. 11 is not found in all 3. 13 is not found in all 3. 2 is not found in all 3. So The factor of 3 is the only common numerical factor for all three of our terms. Now we'll take a look at the variables. xy, xy, xy. All terms have some amount of x and some amount of y. Let's check out the powers. We've got power of 5, power of 3, power of 2 for the base of x. So 5, 3, and 2. 2 is the lowest number, so that's the one guaranteed to be found in all terms. Next, we'll look at the bases of y. Here we have 7, 3, and 4. 3 is the lowest exponent, so that's the one guaranteed to be found in all terms. And now we have to figure out what other quantity is left. Now that we found the greatest common factor, we also need to write the remaining factor. So 3 times 9 will give us 27 from that first term. We have x squared. We need x to the 5th. 2 plus 3 more would make 5, so that means x cubed is the missing amount. Bases of y. We have 3. We need 7. So 3 plus what makes the 7? That would be y to the 4th. Now be careful when you're trying to match the middle term. We have 3. We need to multiply it by something to match negative 33. So that would be subtraction of 11. So 3 times negative 11 matches negative 33. Now we move on to our bases. X to the 2nd, we need x cubed. So one base of x is missing. We have y cubed. We need to match y cubed. Those are the same. That means we do not need any more bases of y. For the last term, we have 3. We're trying to match a negative 78. So I know it's going to be subtraction again. So 3 goes into 7 once, leaving 4 left over. No. 3 goes into 7 2 times, leaving 1 left over. So 3 goes into 18 6 times. So I need 26. Now check out the x's. We have x squared. We need x squared. That's the same. We don't need any more x. Finally, base of y cubed is what we have. We need y to the 4th. So one more base of y is needed. Close that off with a parenthesis. So our final answer is 3x squared y cubed multiplied by this quantity.